you guys have any questions? I don't anticipate this being very, very long today. I have one problem I want to work through with you, but I'll be glad to answer any questions you might have.
I think I'm pretty good right now.
You good? Okay.
I'm good.
Well, that's good then. Let me just, hopefully you have your textbook in front of you. I want to just walk through question number 63. It's on page 456. You'll notice that this question has this little icon beside it that says something about follow the 4-step process. The first couple of years I taught this class, I tried to teach that, but it's really not testable. It's kind of an organized problem-solving process. We kind of walk through all of that anyway as we go through. You'll never be asked on the open response question to follow the 4-step process. So don't worry about it. If you can follow along with what I'm doing, we're touching essentially all the points of that. That's just something that the author of the textbook encourages students to use as a organized problem-solving process, but I found some students were more hung up on the steps than they were with just dealing with the problem. So I stopped referring to it. So don't worry about it. But the question is this: an insurance company knows that its entire population of homeowners, the mean annual loss from fire is $250, with a standard deviation of $300. And right there, that ought to tell you something about the shape of the distribution. The standard deviation is greater than the mean. And if you think about it, it doesn't make sense to have values less than 0 here. We're dealing with the amount of loss from a fire. And so a negative loss would be a gain, and nobody makes money from a fire on their property. So this should tell you right away that the population, the shape of the population is kind of weird to begin with. Let's keep reading and we'll kind of figure it out. The distribution is strongly right skewed, which is what we would expect. Many policies have no loss, and a few have really, really large losses. If the company sells 10,000 policies, can it safely base its rates on the assumption that its average loss will be no greater than $275? Okay. So here we have a case of a non-normal distribution for the population. It's clearly skewed to the right, and probably very skewed to the right, as you can imagine. If somebody insures your house against a fire and your house burns down and it's a total loss, then that's a really, really, really large loss to the insurance company, certainly far greater than $250. So what we're seeing here is that the few really, really, really large losses, how they balance against the many losses that are many policies that have 0 loss. Most houses don't burn down, and so most insured properties don't collect, so they have a 0 payout for them. So let's just take a look at the question as it appears to us. First of all, we want to ask, really the basic question is, what's the probability that the loss is greater than $275. Another way of phrasing it, which will probably be easier for us to calculate, is what's the probability that the loss is less than $275. So that's the way we'll attack this. Is we want to draw our line in the sand at $275 and see what that loss is going to be, or the probability of that's going to be. So first of all, we notice a couple of things. That in the number of samples is quite large, 10,000. And if we've learned anything so far, I hope it's this, that a large sample size is really, really, really beneficial. And in this case, it helps us out a great deal in answering this question. So two things happen here. First of all, since the sample size n is quite large, we can rely on the central limit theorem here. And so regardless of what the parent population looks like, our sampling distribution of sample means is going to be normally distributed. N is large enough to satisfy the central limit theorem. And we can safely say that our sampling distribution of sampling means is normal. So that allows us now to determine a mean and standard deviation. So the mean of X bar is simply going to be the mean of the population, which is $250. Okay, so now we know where our sampling distribution is centered, and we need to figure out what the standard deviation is. So the standard deviation of X bar is the population standard deviation divided by the square root of n. And that population standard deviation, we said, is 300 divided by the square root of 10,000. Well, 10,000 is 10 to the fourth, and so the square root of 10 to the fourth is 10 squared. So that is 300 divided by 300 divided by 100. So the standard deviation of X bar is just going to be $3. So at this point, we can say, even if I sketch the population, let me just, and I don't know, hopefully you can see this here. The parent population is something like this. There are many of the policies have very low loss. Several of the policies, or a few of them, have very high loss. The mean here is at 275 or 250. Our sampling distribution of sample means, though, is going to look something like this, and the standard deviation is only $3. So 275 in this graph, the scale of this graph is going to be way over here. And so we can now look at graphically, hopefully kind of lead ourselves in the direction that we want to go. That I don't expect this to be very likely that we're going to have much area down here. It's going to be very, very unlikely. So what I'll do is I'll just use this little board here. We know that we know our mean and standard deviation now, so we can just calculate a z-score. The z-score is our X value. The value we're interested in is 275. The mean is 250, and the standard deviation is 3, which leaves us with 25 divided by 3, which is 8 2/3. No, 8 1/3. So 8.33. Okay, so here's what that calculation would look like. The z-score is 8.33. Well, if you look at table A only goes to 3.5. You could use the calculator and calculate the probability, but it's going to be a number I didn't even calculate. It's going to be so small. So what we can conclude, the probability that Z would be greater than 8.33 is going to be approximately 0. Okay. Because 8 standard deviations away from the mean is such a small number that that area is going to be very, very small. It's approximately 0. So the answer to our question then is, let's see, can it safely base its rates on the assumption that the average loss will be no greater than 275? And the answer to that is yes. They are very safe in assuming that their losses will not be greater than their mean loss will not be greater than 275. Quite honestly, they're pretty safe in saying it's not even greater than 260, but 275 gives them plenty of room to operate on and be sure that they won't be above that value. And so that's kind of a very good example of how the central limit theorem, and in combination with a very large sample size, gives us very good clarity about a population whose shape is clearly not normal, but it gives us clarity about what is the mean of the population, and we can use that in a practical way, like the insurance companies, to calculate what its rates going forward should be for the next year. So honestly, that's really all I want to share for today. Like I said, unless you've got questions, this will be short. I'm like you. I'm looking out the window. It's really, really tempting to go outside and get some fresh air. So again, unless there are any questions, we'll call it done for the day. And done for the 2 weeks. We will get back together formally on April 13th. I'll plan for 1 o'clock, and hopefully we'll know for sure what the rest of our year is going to look like by then. At this moment, I don't know. All I know is that we're out till at least the 20th. And we'll go from there. I look forward to seeing you. If you guys, I know some of you are still working on some of the assignments. Feel free, keep working on those over the break, and turn those in. If you've got questions, I'll be monitoring Google Classroom every day. I'll be monitoring email every day. Be sure to reach out and ask me any question you might have. I'll be available to get on a video chat with you if need be, and we'll go from there. All right. Any last questions? Well, I hope you all enjoy your break. I can't wait to see you. Maybe we'll bump into each other somewhere at a very safe distance. And I look forward to seeing you again soon. Y'all take care.